The Today in Manufacturing podcast offers a powerful and unique perspective on the biggest stories impacting U.S. manufacturers. Anna Wells, David Manty, and Jeff Ranke apply their experience as editors of industry-leading brands Manufacturing.net and Industrial Equipment News in providing in-depth analysis of the latest headlines. Their insight, along with a mix of humor and human interest, makes Today in Manufacturing a go-to source. Keep pace with supply chain challenges, electric vehicle developments, labor struggles, robotics, and more by listening, downloading, and subscribing to the Today in Manufacturing podcast.
Researchers from the University of Washington want to improve the pipe. Specifically, they're developing a flexible pipe with an interior helical structure that makes fluid flow one way and not the other. In the latest example of nature-inspired biomimicry, the team turned to shark intestines, and their new prototype stands to make a significant impact on everything from medicine to engineering. When it comes to getting fluid to flow in one direction, designs like those found in engines have traditionally leaned on flaps. Unlike human intestines, which are more or less hollow tubes, shark guts have a network of spirals surrounding an interior passageway. Previous work has suggested that this unique structure promotes one-way fluid flow or flow asymmetry.
We start in the alimentary canal and open the digestive tract.
UW postdoctoral researcher Ido Levin, lead author of the new paper published in the Proceedings of the National Academy of Sciences, says flow asymmetry could have tremendous technological potential, but the mechanism was puzzling. It was hard for Levin and his team to determine which parts of the shark's intestine contributed to the asymmetry and which simply increased surface area for nutrient absorption.
Let's cut it open. Whatever it's eaten in the last 24 hours is bound to still be in there.
To test their theory, the team 3D printed several biomimetic pipes with interior helices inspired by shark intestines. The first pipes were printed with rigid materials and performed well in unidirectional flow. Now, this has been attempted before, and by a rather notable inventor, Nikola Tesla. Perhaps you've heard of him. More than 100 years ago, he patented the Tesla valve, a one-way fluid flow device with no moving parts. However, as the team tuned their design and printed new iterations, the flow asymmetry rivaled Tesla's design. Levin was notably excited, stating, quote, "You don't get to beat Tesla every day." To top Tesla's design, the researchers looked at the pipe's rigidity. After all, shark intestines aren't rigid. The team tested, quote, deformable structures made from flexible materials. They 3D printed prototypes using the softest polymer available. The flexible pipe designs performed at least 7 times better than all previously measured Tesla valves. The work could not only lead to new pipe designs, but also new materials. While many various 3D printed materials are commercially available, the researchers say the market still has a lot of room to grow. For example, actual intestines are still about 100 times softer than the softest 3D printable material. I'm David Manty. This is Manufacturing Now.